like that one.
Thank you. Swing it over to you, Tom. What do you got for me?
I got two articles that sort of talk about the same thing. So I'm coming to you first about superconductors again.
Oh boy.
And here's why. It actually follows up great along your fake news story. I read a buttload of stuff on Twitter about superconductors all the time. Week after week after week, I'll read an article about superconductors.
What is a superconductor for those at home
so
that
that's,
might not
first
know?
of all, I wanted to start it. They're everywhere. A superconductor is a material that will allow electricity or heat or something to flow through it without any resistance at all.
Okay. So,
for example, if you have electricity flowing through a normal circuit, there is some sort of inherent resistance for that electricity to travel through your circuit.
mm-hmm.
Just makes sense, right? It has to travel through something. It takes energy.
Okay.
So the drive behind a superconductor is that you will get this movement through your circuit with zero resistance, that it will take no energy to do it.
Gotcha.
So can you see the appeal to find these things?
Absolutely.
So they're always
Drives
there.
the cost down, for sure.
Exactly. So I've heard about superconductors a million times, but here's why I want to talk about them right now.
Mm-hmm.
Read an article. It was called "Give Double Layer Graphene a Twist and It Superconducts."
Oh, really?
So here's basically what they say. They talk about they've talked about graphene many times when talking about superconductors.
Mm-hmm.
Graphene is all made of carbon, similar to how diamond is all made of carbon, but unlike having a strong, rigid structure and being super tough, graphene is a single layer of atoms. It's super, super thin layer of carbon atoms, and it's known as graphene. So
similar to graphite, that's the shit you find in your pencil?
Exactly.
All right, cool.
So you get a rub of that off, and you'll get a layer of graphene.
Mm-hmm.
So they've tried to use things like this for superconductors for a while, and this is a new study saying that now instead of having one graphene layer, let's add another layer on, and if you put it at an angle of 1.1 degrees, you'll be able to get some sort of superconductivity than just the single graphene layer before.
Interesting.
Okay. So kind of cool, but you still got to cool it down to 1.7 kelvins, which is minus 271 degrees Celsius.
Cold.
And it's still cold, and we're still nowhere near close to using superconductors in our circuits. Okay. So that's another article that I read. Here we go. That's kind of the way we are with superconductors right now. That's sort of where we're at.
Where it's like we can achieve it, but what cost effectiveness? And
are you using your iPhone at negative 270 degrees Celsius?
Right. No,
not even close.
Not even close.
Okay. So that's why I wanted to share that one. Let's move on to another one about superconductors. This one, they're claiming from meteorites. They found little pieces of superconducting material inside meteorites.
Mm-hmm.
So I was like, okay, I've read a million stories about superconductors here on Earth, and we're nowhere near closer to really utilizing them. Is this a cool new avenue to look for superconductors?
Right.
So, read the article, checked it out, and basically what they're saying is that it's really cool and novel that we found superconducting materials in meteorites. Really cool that they would have formed under these different conditions of pressure and heat out in the universe. But even when we get these materials down here to Earth, it's the same thing.
Same problem.
They won't act any more like a superconductor than any of our other materials and methods that we've done. And it's sort of a novel thing that we found some of these materials in meteorites.
Right. Now, here's the thing, though, Tom.
Sure.
Is that meteorites, when they're meteors still
out there in
space, doing their thing, flying space rocks.
Yes.
They're cold, right? Cold enough to be superconducting.
Exactly, because they're in the, what is it called?
The interstellar medium.
Exactly. Yeah. They're out there in space where there is no heat.
Right.
So they sort of gain these properties based on that. They're in those conditions. But when they make it here to Earth, that's the problem.
Right.
They're on our conditions now.
So will superconducting, do you think, as a science, exist solely as something that we do in spacefaring ventures, where
Possibly,
the conditions are
ripe for it?
Kind of ideal for it just naturally?
That's a great point. I definitely see it moving that way now you say it.
I could, yeah.
And just wanted to read a quote from here. At point, this is novelty. And another one, that while superconducting materials found weren't new to science, additional interplanetary interlopers, that's a good way to put it, might harbor new, more technologically appealing varieties of superconductors. So once again, we're not really gaining any new type of information. We're sort of just learning the story of these meteorites and learning a little more about them.
Right.
So I wanted to talk about this now because when you see things about superconductors, I read about them all the time. You don't really get too much of the new wow factor that you're looking for. It's sort of the nitty gritty. We tried this and now we learned this, and it's kind of moving at a slow pace now. But
Interesting.
You never know, right?
Yeah.
There might be a breakthrough, and then we'll let you know.
Yeah, it would be fascinating for some kind of spacefaring company to take advantage of that fact, though, right?
That
Because,
when it is super cool, then you can do it with no energy.
right.
So
NASA has had some robotics land on meteors that are or comets that are kind of traveling around the solar system. So it would be fascinating to see some sort of use of the fact that they have superconducting materials inherently on them, and could we just run the systems that need to run to study what's going on on this
using
space
that-
rock, using the fact that it's free electricity, basically. That would be fascinating. It would be hard to do in practice, of
in
course.
practice, yeah.
But
But I could actually see it, yeah, going in the space direction before we actually have any sort of practical superconducting use here.
yeah,
But you never know.
yeah,
One dude needs to make one crazy breakthrough. I mean, dudette dude as well.
right.
Yes.
Yeah, where there's a will, there's a way. Exactly.
Exactly.
Yeah, for sure. for
Cool.
sure.
So that was my two articles that kind of related. That I read so much about superconductors, I need to get it off my chest.
Okay. So you got 4 articles altogether.
The other two are kind of connected as well.
So you're a cheater.
I'm a cheater.
You're a cheater, is what you're. No, I'm just kidding.
I'm just kidding. So yeah, hit us
Very
up,
cool.
John.